Okay, so welcome to class. Here's the first thing that I need for you to get out. I need for you to get out yesterday's worksheet, this one, and your formula sheet. Now, if you weren't here yesterday, on my front lab table, kind of where Mrs. Cunningham is standing, there's a small packet. The small packet looks like what's on the screen. Would you please come grab it? We worked through this whole packet yesterday. You should do that on your own. Now, for those of you that have it out, yesterday we talked about weight and mass. And weight is the measure of the force of gravity, and mass is the amount of matter. Now, if you're looking at your formula sheet, you should have the equation that's on the board. You should have weight as a gravitational force, and it's in newtons. You should have mass as the amount of matter, and it's in kilograms or grams. And you should have gravity on Earth is 9.8. Now, what we did a little bit of yesterday is just looking at different planets and what your mass would be on different, or what your weight would be on different planets. Okay. So the most information that you need are these little pieces of information that are on the worksheet that are right in front of you. Now, for those of you that were here yesterday, I got to some of yours, but not all of yours. Take a look at the screen so that you can check your answers. Just see if you're okay. So mass is the amount of matter, weight is the gravitational force. What will happen, if anything, to the mass and weight? Well, the weight's going to go down. Why would this happen? Because gravity on the moon is less. Number 4, you should have 588 newtons. Remember, you're getting 4 points for each physics problem: equation, number substitution, answer, and unit. 4A, you should have 58.8 newtons. Number 5, 1.64 meters per second squared. 6A, 21.56 newtons. 6B, 8.14 newtons. 6C, 8.9 meters per second squared. Then number 7A, you should have 23.1 meters per second squared. B, you should have 0.6 meters per second squared. And C, you should have 4.9 newtons. The biggest thing about these physics problems is just making sure that you put the correct unit on whatever they're looking for. So weight is in newtons, mass is in kilograms or grams, and gravity is in meters per second squared. Okay, now you'll want to leave this worksheet in front of you with information on weight and mass. And you might even want to have your formula sheet in front of you. Now you're also going to want a calculator. And then you're going to want to get your quiz or your computer out, because now you're going to play a quick game of quizzes. You're going to have about 10 minutes to play once you get started. Top 3 are going to get a piece of candy. Okay, you don't need your computers anymore, so you can close your screens. Now, today we're going to do a little activity. Inside of the packet that we did yesterday is this little gravity lab. Looks like this. But before we get started on this, I've got a little video for you. This video compares jumps on different planets. It's just a short little guy. You're not going to jump up. You're going to jump out today. So take about 3 minutes to watch this video. Okay, so because different planets have different masses, gravity is different on different planets. Gravity depends on the mass of the object and the distances between them. So today, what you're going to figure out is your weight on different planets and how far you would jump on different planets. So in order to calculate your weight, you need mass times gravity. The problem is that you don't know your kilograms. Because we're in the United States, we use pounds. We don't know our kilograms. So the first thing I need you to do in figuring out your weight on Earth is to take your pounds, whatever you'd weigh when you step on a scale, times 0.45. Now look, if you want to live the 1,000-pound life today, I don't care. Whatever you want to weigh. If you want to be a pair of 600-pound sisters, also fine with me. I just need you to have some number that is your pounds, and I need you to multiply that by 0.45. I've got it on the screen. Now, when you do that, you will get your kilograms. And let's just say your kilograms are 78 kilograms. You're not done yet, because when you're calculating your weight, you have to take your kilograms times 9.8. So now you're going to take whatever your kilograms are times 9.8, and that answer is going to go all the way down here. And then you can do the math. I'll give you about 3 minutes to do the math. Okay, so now you've got your weight. You should weigh the most on Jupiter. Now what you're going to do is you're going to go outside, and right outside the guidance office door, I have tape meter sticks laid out. And those meter sticks are either 3 or 4 meter sticks long. And you will jump from the concrete into the grass. Now look, my recommendation is that you do a standing long jump, meaning you're not running and jumping. But because I know that there are boys in this class that will want to run and jump, it could result in you landing on your buttocks, and you could be embarrassed about that. But remember, I said just do a standing long jump. So when you go outside, you will jump, and you have to do 5 jumps. Now, what I've recommended for all the other classes is they just take their phones out with them, open up a note in your phone, and just put your measurements in your phone, and then walk back in and record them after you get done jumping. Also, you can record on the front of your feet, not the back of your feet. In the long jump in track and field, we record the back of your feet, but you'll get further if we record the front of your feet. So if you all head out there right now, you can jump on either side of the meter sticks. There are about 6 places that you can jump. You should get done in under 10 minutes. And then you'll come back here and calculate your averages and then calculate your length. All right, I hope everybody wound up okay there. No broken bones. So now what you need to do is you need to add all of your jumps together and divide by 5 and take your average and put it in the average length of the earth and then calculate your jumps. When you're done with your jumps, there are conclusion statements on the back that you need to write, and that should be due. You can just tear that out of your packet and hand it in, hopefully by the end of class today.